how do you evaluate your trig functions right now? Off the two triangles, right? So if I give you a sine of pi over 6 or cosine of pi over 4, you need to come up with a triangle first, and then you can do sine, cosine, and all that. So hopefully you have somewhere in your memory bank your two special triangles. Right, you have the pi over 4, which is the same thing as a 45-degree triangle, 45, 45. And then you have pi over 6, which is the same thing as 30, 60, 90. Pi over 6, pi over 30, 90. And then how do you fill these out? Pi over 4, the 45-degree one is hopefully not too bad. Yeah, you start with 1 on one of the legs, then the other leg has to be 1 because these are the same. And then you do the Pythagorean theorem and you get root 2. Here you start with 1 on this leg, and then it's 1, 2, 3, but except root 3. So if you know both of these triangles and you know your definitions, SOHCAHTOA, hopefully you can find sine, cosine, and tangent of any of the special angles. But this is kind of, how do I put it? This was necessary information. I guess if you didn't get it yet, it would be good for you to have it now. But as we do the unit circle today, we will be using these two triangles and incorporating it into a nice, safe way of remembering this. Okay, so if you haven't memorized this yet, I'll give you maybe a faster way to remember. As far as the cofunction problem goes, make sure you understand that problem sometime before we take our test next week, because I will probably, what I've decided I think I'm going to do, I'm not positive, but I think, I'm going to look, because I'm keeping stats on all the problems, and I'm just going to take the problems that you missed the most on quizzes and put them back on the test to see if you did your studying and figured them out. Okay, so I did it on the board. I did one of them on the board on Wednesday last week, so hopefully you can figure it out. Other than that, the other announcement I have is that I have a review sheet up for you somewhere. It's under the study guide, the study aids. Right, so scroll a little bit past my table here in the 127 study aids. This has all the stuff I'm kind of getting together for this class. And you'll see right at the top, review sheets, exam 1 review. Exam 1 is going to cover 6.1, 6.2, 6.3, and then 8.1, which was the right triangle trigonometry. And this is your review sheet. 15 questions with about H parts each, so something like 105 questions. Start working on that. I don't have any answers yet, but I will work on answers next week, or this weekend. Friday and Saturday I'll post answers while I'm posting videos and stuff. Okay? So that's your review. Remember, the exam is not this Wednesday, but the following Wednesday. All right? So the date is the 19th, I believe, if you look on the home page here. Exam 1, February 19th. That is the day after President's Day, I think? We have a holiday on Monday, this Monday. Okay? So I will not see you this Monday. You will come in cold on Wednesday and just take an exam. Just see how it goes. If you have questions, of course, you can email me or come to my office, go to the tutoring lab. I will be in on Tuesday, and I will be in my office from 1 to 2. And then on Wednesday, I won't be in my office before I see you. So it'll be, if you want to see me, you better make time to see me on Tuesday. Or start the review now and ask me questions about it Wednesday or Thursday. But any general administrative questions about what's going on? I mean, I'll answer homework questions in a second, but anything about what's going on in the class, or what you should be doing? All right, how about homework? You guys start anything from 6.3? Anything giving you trouble?
21.
Okay. I don't know what that says.
And 21 pi.
Ah, gotcha. All right, so number 21 on 6.3 has to evaluate tangent of 21 pi. And it probably says find the exact value of the trig function or something. So we're trying to figure out what tangent is at 21 pi. Do you remember what the strategy is for something like this? graph it first, right? So first you have to figure out where this lands. So where's the angle 21 pi land? No, not, where's the, okay. Where's 1 pi land? Right here on the negative x-axis, right? So this would be 1 pi. Then if you keep going around, this would be 2 pi. Right, starting from here, 0, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi. You see the pattern? Right, all the odd pi's land here. So these are all odd pi's. These are all even pi's. So 21 pi in particular is going to land right here. Now, usually what we would do, right, a couple of examples we did in 6.3 or last time, if our angle landed right over here, say, we would draw a right triangle using our reference angle. We would pick off our reference angle, whatever it was, and we'll draw a right triangle. Okay? This is kind of the normal case. This is a special case because you land right on the axis. So you remember how to handle this situation if you land right on the axis? Who? What?
Did I say that one?
I don't know, I didn't hear.
Y over R?
Yeah, okay, so remember your trig functions had a bunch of definitions, right? Like sine of theta. Originally we called sine of theta opposite over hypotenuse, but then when we brought it into this new context, we called it y over r. Right, like this is y, this is x, this is r. So y over r is sine. Cosine theta is x over r. Tan theta is what? Y over x. So what I need if I'm going to evaluate tan theta is a y and an x. So I have to pick a point on this red. I can't draw a triangle, but I can pick a point. So what's a point on the negative x-axis? Any point in the world. Negative 1, comma 0. Right? Anything on the negative x-axis is going to have a negative x value and then 0. So then you can evaluate tangent using this definition of y over x. Y is 0. Right? Just look at the point. What's the y coordinate? 0. What's the x coordinate? Negative 1. So in most cases, you're going to be able to draw a right triangle, and then you go back to these special triangles. But if you land on the axis, then all you need to do is pick a point on that axis and use your y over x or x over r or whatever your definitions were from 6. What else gave us trouble?
15.
What was it?
The similar thing, cosecant of 450.
Cosecant of 450. Ah, I see. So again, this one sounds like it's going to land on the axis. Right? Cosecant of 450 degrees, so this is number 15 from 6.3. Oops. Again, if you want to evaluate these trig functions of obtuse angles, of angles that are bigger than 90, you want to draw a picture first. So we figure out where 450 lands. In my head, I start with 360. I know 450 is bigger than 360, so I start with 360. Right, 360 degrees is going to land here. And then how far is 450 past 360? 90 extra. Right, so 450 is going to keep going and land up here. This is 450. So the question becomes, well, two questions. One of them is, what point can I use on this axis?
0 and 1.
0, 1, right? Any point on the positive y-axis will work. Might as well use 0, 1 because it's the easiest. That's the first question. Second question is, what's your definition of cosecant?
1 over y.
If with the unit circle, it's 1 over y. But in general, for this section, it was r over y. Remember, we had this definition of our 6 trig functions with respect to y, x, and r. And cosecant is the reciprocal of sine, so instead of y over r, cosecant is r over y. What was r again? R is the hypotenuse, but there's no right triangle. So how do we find r in this case? What?
The square root of x squared.
Right. R is the square root of x squared plus y squared. Right? So usually if there's a right triangle, if you have this picture, where this is x and this is y, then r is the hypotenuse, and you find it by doing x squared plus y squared square root. But this idea of trig functions of any angle extends further than right triangles. And so you can do the same thing here, it's just to find r. There's no triangle, you just use the formula. So what does r become in this case?
Square root of 1.
Square root of 1. Right, because x is 1, or I'm sorry, x is 0, y is 1. So if you calculate r, you'll get 0 squared plus 1 squared, which is just 1 squared. 0 squared plus 1 squared, r equals square root of 1, r equals 1. So I need r over y, r is 1, y is also 1. So cosecant is 1 over 1. This is a little too much work. For me, I'm a lazy person. Once we get through today's lecture, we'll have a really easy way to figure all these out, I feel, in my opinion. But this is possible. This is doable. Doable. You just use these definitions word for word. What else?
Number 50. 50.
50. What's 50 give you?
This is the sine of beta
Okay. Sine theta equals
at negative 2/3.
negative 2/3. Okay, so number 50, this is 6.3, gives you sine of theta equals negative 2/3, and it probably gives you some other piece of information.
Yeah, and pi is less than theta, which is less than 3 pi over 2.
All right. And it wants you to find the values of the 5 other trig functions of theta. So they're giving us one trig function, one piece of information about theta. Right there. Well, 2 pieces of information about theta, but only one trig function. Sine of theta equals negative 2/3. But then also, theta is between pi and 3 pi over 2. So this is the last thing we talked about on Wednesday. We did one example. I said I'd do another one today. Certainly I'll do this one now. This is a little different than this kind of example here, right? Because I don't have an angle. They haven't told me what theta is here. Here they told me exactly what theta is, so I can draw an exact picture and use my definition. Here I don't know what theta is, so I have a little bit more work to do. That's okay. I know at least the quadrant of theta. Right, this is giving you information about the quadrant of theta. And what quadrant is theta in?
3.
And how do you know that?
Because it's less than 3
Theta is
pi
in
over 2.
between pi and 3 pi over 2. Right? That's what this is saying. That's the way you can read this. Theta is in between pi and 3 pi over 2. So all you have to know is where pi and 3 pi over 2 is. Here's pi. Here's 3 pi over 2. Theta's in between there. So wherever theta lands, it's going to be somewhere in the third quadrant. So I draw the schematic. There's theta. Theta is actually the angle that starts on the positive x-axis and goes all the way around into the third quadrant. But when I start actually trying to solve for cosine of theta and tangent of theta and all those other trig functions, what I would really like to have is, what I would like to have, because I like pictures, is a nicely labeled right triangle. So what I'm going to do is focus on this reference angle here and draw this right triangle. And using sine of theta equals negative 2/3, using my only other piece of information, I'm going to solve for all the side lengths here. So sine, you can either remember it as y over r or opposite over hypotenuse. Either one will give you the same thing. I like opposite over hypotenuse because that's how I was trained. So opposite over hypotenuse means that I have 2 over 3 for my sine value. Meaning my opposite is 2 and my hypotenuse is 3. So I'm going to come here and put a 2 and I'm going to come here and put a 3. Opposite is across from this angle, 3 is the hypotenuse. Talk to me about sines, S-I-G-N-S.
You need a negative in front of the
The 2 should be negative no matter what because it's going down. Now I don't know what this side length is. Can I calculate it?
Yes.
It's going to be negative though.
It's going to be negative definitely, right? Because it's into the third quadrant. It's going to the left. And I can calculate it by doing what? Pythagorean theorem. You have 2 side lengths on a right triangle, so you can do the Pythagorean theorem. Now be careful, you're not missing the hypotenuse. Some of you fell for this on your quiz. You're not missing the hypotenuse, you're missing one of the legs. So this is like a. You're going to do a squared plus negative 2 squared equals 3 squared. If you're solving for this, call it a for a second. If you're solving for this, you have to calculate a squared plus negative 2 squared equals 3 squared. Or a squared plus 4 equals 9. Or a squared equals 5 if you subtract. And then when you square root both sides, a equals plus or minus root 5. Right, so when you square root both sides, you get plus or minus options. But because we know our triangle is going to the left, we're going to choose the minus option. So we like this one, we hate this one. So down here for my adjacent side, I'm going to put negative root 5. Actually, I'm going to put it in green because his friends are green. He's feeling left out. So step 1, I figured out my quadrant. All right, that's the first thing you have to do. Step 2, I went ahead and drew my right triangle, labeled my right triangle using the value that they give me. All right, so these 2 things were step 2. Step 3 was the Pythagorean theorem with the right sign. And then finally, I can solve, now that I have this triangle, I can solve for all my other trig functions pretty easily. Step 4 would be to find all my others. So start with cos theta. Cos theta is forever and always adjacent over hypotenuse, negative root 5 over 3. If you like the other definitions up there, you would do x over r, but x is clearly negative root 5 and r is 3. So you then you go on to tan theta. Tangent is opposite over adjacent, or y over x. Opposite over adjacent. So negative 2 over negative root 5. Which you'll probably rationalize and get rid of the negatives. Plus. So 2 over root 5 rationalizes. Root 5, root 5. So 2 root 5 over 5. go. Now you do your reciprocals. Cosecant, secant, cotangent. What's cosecant? Yeah, cosecant's the reciprocal of sine. So you take whatever fraction sine was and flip it. 3/2, but it was negative, so you put a negative. Secant's the reciprocal of cosine. Cosine was negative root 5 over 3, so you do 3 over root 5, still negative. But then you got to rationalize, and it becomes 3 root 5 over 5. And then cotangent, which I was optimistic about fitting in there. Cotangent of theta is the reciprocal of tangent. I would probably go back to this original guy when I took my reciprocal. Root 5 over 2. Otherwise you have to rationalize again. And if you flip this guy, you have to rationalize again. What do you think? Yes, sir. You were just waving at me. I feel happier now. What else? That's it? Mm-hmm.
Did we do the let f of x equals a sine 3x, find a so that f of 7 over 4 pi equals 1 minus f?
Have we done? Do you have all the tools to do that? Yes. Have we done anything like that? No.
Okay. So should we do it or?
Would you
or
like me
wait?
to? Waiting isn't going to help. Waiting isn't gonna, like. There's nothing I'm going to say that's going to make it
Okay,
easier.
so
we can
do
go over
you
now.
want to just look at it?
Sure.
This might make more sense.
Sure. No, I'm. Did you?
Okay.
Yeah.
Yeah, just right.
Oh, this is for mine. Gotcha. Gotcha.
Yeah.
Gotcha. Which this is. Yeah. I'm gonna pull that. So one of the, remember I told you there's some extra practice problems on this website here from 6.3. Although this looks pretty atrocious. But if you go to the extra practice problems, she's looking at problem number 3 here. Which is good to talk about. So this is kind of a more challenging problem, right? It's not as cookie cutter as the other one. I give you a function f of x equals capital A sine 3x. So this is number 3 on the extra practice on my website. So first of all, and this is a good problem to think about. But before I go through and try to do any of this, I need to talk about what all of this means. This 3 in here and this A out here mean different things. The way, you guys remember how functions work, right? Right, a function f of x is like some machine. You put an input in and then you get an output out. Right? And I'm telling you over here to put in the inputs of 7 pi over 4, for example. And I'm telling you to put in the input of 4 pi over 9. So when you see f of 7 pi over 4, you're thinking you want to put 7 pi over 4 right here for x. And see what happens. But what you have to be careful of is that this 3 is directly multiplied by the angle x, directly multiplied by the input x. So you multiply by 3 before you get to the sign. So you do this first. And then this A on the outside is actually multiplication afterward. It's multiplication again, but it's after you evaluate the sign. I mean is, let me, for example, figure out what f of 7 pi over 4 is, which is part of the question. So in order to do f of 7 pi over 4, I take my function here and I rewrite it, but instead of writing x, I write 7 pi over 4, like this. I put parentheses to indicate that this whole angle, whatever this multiplies out to be, is inside of the sign. Meaning, like, you can't pull this 3 out or anything. It's just trapped in here with the angle 7 pi over 4. Now, before I continue and actually evaluate what sine is, I need to do this multiplication. So how do you multiply 3 times 7 pi over 4?
Minus 3 by 7.
3 times 7, yeah, it's just, this is, you think of this as fraction multiplication, 3 over 1 times 7 pi over 4. So you'll get 3 times 7 pi, which is 21 pi, over 4. Now this I can evaluate. This I learned how to evaluate. How do I evaluate sine of 21 pi over 4?
Turn it into a mixed number.
Right, turn it into a mixed number so that you can graph it, and then you figure out which quadrant you're in and do your reference angle and all that business. So 21 pi over 4, 4 goes into 21 5 times with a remainder of 1. All right, so 21 pi over 4 is going to be the same as going 5 and 1/4 pi. So where's 5 and 1/4 pi then?
45 degrees.
In which quadrant?
1 verse.
First? Third? Third. Right, because 1 pi is right here. 2 pi, 3 pi, 4 pi, 5 pi, and then 1/4. So this is 5 1/4 pi. Now you're right, it's a 45-degree reference angle or a pi over 4 reference angle, right? This portion left over is pi over 4 because we only went 1/4 extra. So when I'm actually evaluating my trig functions, I'm going to use a pi over 4 right triangle, which means I have 1, 1, root 2. Triangle is 1, 1, yes, right. So this triangle is positive 1, root 2, but this triangle is in the third quadrant, so you have to worry about your signs. Right, in the third quadrant, you're going negative this way and negative down. So this will be negative and negative.
And then R is always positive.
R is always positive. Hypotenuse is always positive. So then what does sine of 21 pi over 4 equal? Negative root 2 over 2. Or opposite over hypotenuse is negative 1 over root 2. But when you rationalize, remember we usually rationalize that root 2 and put it on the top. So if you multiply by root 2 over root 2, you'll get negative root 2 over 2. This A, I haven't gotten to the A yet, I'll use it in a second, but this A is still hanging out in the front. Okay? So far so good. So that tells me what f of 7 pi over 4 is. What about the second function here? F of 4 pi over 9, how do I figure that out? It's all the same, same strategy. If you want to know what f of 4 pi over 9 is, plug in 4 pi over 9. So A times sine of 3 times 4 pi over 9. So I just took the x and replaced it with 4 pi over 9. So does that mean I do sine of 4 pi over 9 now? No, what do I do? Multiply by 3 first, right? Before you try to do a sine or a cosine or anything like that, take care of this extra number inside. So 3 on top, 9 on bottom, this is going to reduce. Right, you'll get a 1 on top and a 3 on bottom. So it becomes a sine 4 pi over 3. How do you actually calculate sine of 4 pi over 3? Draw it. Where's 4 pi over 3 land?
Positive x-axis.
Where? 4 pi over 3, that's 1 and 1/3 pi. So third quadrant again. So I'll go pi, but then I'll go 1/3 pi past it. So I'll be down here. So this is 4 pi over 3. So then my triangle will be right here. What's this extra angle left over? Pi over 3, right? I went 4 pi over 3 altogether, but I only went 1 pi over 3 past the x-axis. So then I know I'm in this situation. And I can label my side lengths. Across from the pi over 3 is the root 3. Across from the pi over 6 is the 1. So it'll go something like 1.
Negatives?
Absolutely negatives, right? Because we're in the third quadrant. Don't forget those signs, those are very important. So then, sine, sine of 4 pi over 3 will be opposite over hypotenuse. Opposite is negative root 3, hypotenuse is 2. So that's the trig. We still have some solving to do. Yeah, that's the trig. Okay, the trig comes down to plugging in the numbers given, first multiplying by 3, and then actually doing your graph and evaluating sign. Okay, remember multiply by the 3 first. But now what do I want to do with these two results that I got? Plug them into this equation. Right, figure, plug in f of 7 pi over 4 here and f of 4 pi over 9 here, and then solve for a. So I want to solve for a in the equation f of 7 pi over 4 equals 1 minus f of 4 pi over 9. So in place of f of 7 pi over 4, I'm going to put negative root 2 over 2a. I changed the order just because we're used to writing the variable last. It's multiplication, so you can write it in. 1 is going to stay 1. Minus is still minus, but then in places of f of 4 pi over 9, I'm going to put negative root 3 over 2a. Now I have to solve for a. How do I do that?
Can you add the root 3 over 2?
Yeah, well, so first of all, this minus minus is really irritating me. So I'm going to change this to 1 plus, right? Minus minus. So we'll make it 1 plus root 3 over 2a. And then a is your variable, so you want to get everything with an a on one side and everything else on the other side. For example, I'm going to add my root 2 over 2a to this side to get my variables together. And I'm going to subtract my 1 to get rid of the constant onto the other side. So negative 1 equals root 3 over 2a plus root 2 over 2a. Then what?
You can add them because they're like terms.
They're like terms. This is like 5x plus 4x gives you 9x, right? You just add the things in front. So if you have root 3 over 2a plus root 2 over 2a, this will be root 3 plus root 2 over 2a. Should absorb that because I know you mind a little bit. Yeah, grant. So when I have a plus a, I can just add the things in front. How do you add root 3 over 2 plus root 2 over 2? Well, they're fractions. So to add root 3 over 2 plus root 2 over 2, you add the numerators, keep the denominators the same. You got to add. But then, I'm solving for a at the end of the day. So I need to isolate a, which means I have to divide by this whole mess here. So I did it. But if you take a number and divide it by a fraction, what happens when you divide by a fraction?
Flip it and multiply.
Flip and multiply. So this is really -1 times this. Times the reciprocal of this, I should say. A is equal to -2 over root 3 plus root 2. And if you were super hardcore, you'd rationalize the denominator. Just saying. How would you rationalize the denominator?
Use the conjugate, right?
Absolutely. Because there's a plus in the middle here, if you wanted to get rid of the roots in the bottom, you would have to multiply by root 3 minus root 2. Which would give you 3 minus 2 on the bottom, and -2, so this is equivalent to this. It's just 1 on the bottom. Yes, absolutely. Sure, why not? You can see anything at any time. Because as soon as I say no, you're not going to see it on something, you're not going to study it. And that defeats the purpose. One thing I will tell you about this, the only trig we did was right here. This was the trig. This, all algebra. All 96, for the most part. Not even 126. That's why it's hard, because you guys forgot it. Or at the time, you didn't quite get it 100%. But the trig is right here. I could make a very similar question, but make the answers turn out not to be square roots. And then the solving will be a lot easier. And that's definitely fair game for a test, because you don't have any defense if these aren't square roots. If this is just 1a equals 1 plus 2a, you should be able to solve it. You know what I mean? So this part's a little tricky only because you haven't seen it in a while. This part here, the F notation, this is 126. This is what we did in 126. We talked about function evaluation. You plug that in, this is the trig. So this is definitely a good test problem. Definitely a good test problem. It is maybe not so much because you don't have as much time, but good test problem. All right. Before I erase, questions about anything I wrote there? Or said? Or any questions? Kind of got to get on with it. I'll say one more thing about 6.3, and then I'll do the beginning of 6.2 and then the end of 6.2. Your quiz this week will be over just the problems from 6.3, just the stuff we did from 6.3. So definitely look at these extra problems, those are good, but if you look at the homework here on the homework sheet, the homework was 11 through 57 on 6.3. So focus on those, focus on lecture examples. and I'll have a good quiz for you. Okay, let me talk.
Please keep that to the right of that.
Okay, I'll
So
start
right
tracing here.
Yeah.
Okay. So the first thing I want to do is go over quickly the one example I didn't get to last time, which was here. Oh, it's kind of like the one we did today, but that's okay. That's a little bit. Oh, it's tangent. Good. So this example I didn't get to down here. Example. Where I give you tangent equals something, and I give you another piece of information. I want you to find the 5 remaining trig functions of theta. So we did a problem like this from the homework. This is a little more difficult. So I'm giving you one piece of information, tangent, well, 2 pieces of information. One is about tangent equals some number, and the second is about sine theta. I don't tell you what sine theta equals, but I tell you it's greater than 0. So this is like a puzzle. This, you have to kind of put together the clues to figure out what all the other trig functions are. And if you remember, before what we started with was a quadrant. Okay, I don't know exactly what theta is, but I should be able to narrow down a quadrant. If in the example above this, like I told you specifically, theta is in quadrant 3. Okay? But in this example, I didn't tell you where theta is. You need to, detect it. You need to be a detective. So, what does the fact that sine theta is greater than 0 tell you about the quadrant of theta? And why?
It says that y is positive.
It says that y is positive. You guys understand that? Okay, so what's the definition of sine theta? Right, so at the very beginning when we started defining sine, we said that sine theta was opposite over hypotenuse, right? But now that we went past 90 degrees, now that we're not always dealing with a right triangle, we use y over r. Now what this is saying is that because r is always positive, the only way that sine can be positive, the only way that y over r can be positive, since r is always positive, is if y is also positive. The only way you can get a positive result is if you have a positive over a positive or a negative over a negative. And we can't have a negative over a negative because r is not negative. So one way to sort of go through this analysis is say, all right, sine is y over r. Since sine is positive and r is positive, I know y has to be positive. That's legit. Another way to think about this, or to help you remember what quadrants a certain angle is in, is with this mnemonic device here. All students take calculus. You guys seen this before? So the way this works, this is really just a memorization tool. But if you remember this phrase, all students take calculus, it tells you where things are positive. So what this tells you is that all of the trig functions are positive in the first quadrant. And that makes sense because in the first quadrant, x and y are both positive. So x over r and y over r and all of that will all be positive. In the second quadrant, the way this works is you focus on the s. S associates with sine. So this is telling you that sine is positive in the second quadrant. By association, what's the reciprocal of sine? Cosecant is also positive. Because they're just reciprocals, that's not going to change the positive or negative. But the way the mnemonic device works is if you see S, you think sine's positive. So what do you think is positive in the third quadrant? Tangent. The idea is both x and y are negative, so if you do a negative over a negative, then tangent will end up being positive. And by association, it's reciprocal. Finally, cosine is positive in the fourth quadrant. And by association, it's reciprocal. So, what does that mean about cosine? What's cosine? What's the sign, S-I-G-N, of cosine in the second quadrant? Negative. Because sine is the only one. The sine and cosecant are only two positive functions. All the others are negative. Cosine, tangent, cotangent, secant, they'll all be negative. So either you can remember the definition here and use a rationalization that r is positive, so y has to be positive to make sine positive, or you can memorize this little thing. But somehow you have to be able to go from this statement to the possible quadrants. So the fact that sine is positive tells you you are either in the second quadrant or the first quadrant. Right? Either you go here and say, okay, well, where is sine positive? Well, they're all positive here, sine is positive here, this doesn't work, this doesn't work, because this has no signs. Or you use the fact that y is positive and shade above, because y is up. Y is positive when you go up. Alright, but that doesn't narrow me down to a single quadrant. Remember, to get my trig functions, I need to have a single quadrant to get my SIGNs, my signs right. So how do I know whether I'm in the first or second quadrant?
Second, because x is negative 2.
Go to this tangent value. Tangent's also negative. Well, sorry, not also. Tangent's negative. So this, focusing on this sign here, you know that tangent's negative. The only places tangent is negative, tangent's positive here, they're all positive here, so tangent's negative here and here.
I'm confused. When you planted at sine, and you planted at the cos plus, but how is that negative?
Okay, so according to this diagram, where's tangent positive?
In the bottom left corner,
Or?
or the right corner?
So that's where tangent's positive. So where's it negative?
Oh, okay, so whatever it's not. then it's negative?
Right, it's either one or the other. There's no other choices. So if it's positive, if you know it's positive 1 and 3, then it's negative 2 and 4.
And also, isn't tangent y over x, so since sine is y,
Since y is positive, right? Since y is positive and tangent's negative, you know x has to be negative.
so x would be negative 3, and then...
Right, correct, correct. So either you can use this logic, or you can use logic like this again. Yeah, either one will get you there. But somehow you determine that you're in the second quadrant. Because that's where sine is positive and tangent's negative. That's the only quadrant where sine is positive and tangent's negative. Any other quadrant will not have that attribute. So then I can draw my triangle, and this is just like the problem we did before now. Right, my triangle's in the second quadrant, so I come over here. I draw a triangle. I draw my angle in the second quadrant. My theta. I draw a triangle down here. This reference angle. and I label my either my opposite, adjacent, hypotenuse, or x, y, and r, right? I label my side lengths. Tangent is either y over x or opposite over adjacent. Opposite is 2, adjacent is 3. And from the picture or from our logic before, x has to be the negative value, right, because y is going up. And then how do you get the r or the hypotenuse? Pythagorean theorem. 3 squared is 9. 2 squared is 4. Root 13. Hypotenuse is always positive. So then you can read off all your trig functions. I'd rather not do. But we have tangent data. Let's do sine and cosine, and then you can do all the reciprocals on your own. Sine theta would be what here? So sine theta is opposite over hypotenuse, or y over r, so 2 over root 13. Then you rationalize by multiplying by root 13 over root 13, and you get 2 root 13 over 13. Cosine of theta is adjacent over hypotenuse, or x over r. You get negative 3 over root 13, or when you rationalize, negative 3 root 13. And then the others, the reciprocals, you'll just flip everything. Right? Oh, and here's tangent. So there's our 3 regular trig functions. For the reciprocals, you just flip. Yes?
On a test or quiz, would it be acceptable if we don't draw the graph, but just find the values of x, y, and r, and then solve from there?
You wish. Would you like my warning? Okay. 2 warnings I have for that. 1, if I tell you to draw the angle, then you have to draw it no matter what. Right? There's no option. Second, if you find the values of x, y, and r, students get in the habit of forgetting the quadrant. Right? They'll just say, oh, well, y is negative 2 and x is 3 because of this. And then you have the wrong quadrant because actually x was negative 2, or x was the negative number. So, will I give you credit? Yes, if you answer everything I say and you do it correctly. Yes. Yes,
Why
sir?
do we even use x, y, and r? It's just like calling r the hypotenuse. Why can't
We use x, y, and r so that when we get to the unit circle, it makes more sense. There are fundamentally 2 different ways to do trig. There's right triangles and there's a unit circle. And they all do all the same things. But they have different terminology because in a circle it's a radius and a right triangle is hypotenuse. So they do everything the same, it's just there's different terminology. Why do we learn them both? I don't know, because your next teacher might talk about the unit circle or your next teacher might talk about right triangles, and I don't know, so I'll just prepare you for as much as I can. But yes, at first it's a little bit hard, it's a little bit hard getting the terminology to match up. But x, y, and r, or opposite, adjacent, hypotenuse, are all the same. But I have 20 minutes left, so let me start 6-2 at least.
Can I ask a quick question?
Okay.
How come you put the triangle in that region?
Oh, that was the analysis we did. We decided that it would, wait, I don't understand that one.
Because I was writing the notes for I was a little bit behind on the notes trying to understand what was before that, so I didn't really catch what was to the left, like what you circled. How did you get that?
Okay, so somebody tell me why we ended up in that quadrant.
It's the equation.
There's 2 things that went into this. What went into this? Tangent's negative, and sine is positive. Those are the 2 things you need, right? Either you do this, all students take calculus, which tells you where tangent and sine and all of them are positive, or you use logic about y and x and r. But you need to find the quadrant that satisfies both y is positive, satisfies both sine is positive and tangent is negative. So start with sine is positive. Take this for example. Where is sine positive?
1 and 2.
All are positive here, sine is positive here. So these are your options according to sine is positive. Where is tangent negative?
2 and 4.
2 and 4. Tangent's positive here, tangent's positive here, so it must be negative here and here. So why did I select this quadrant? It's the only one that fulfills both of the needs. Tangent negative, sine positive. So for example, if I gave you cosine of theta is less than 0 and cotangent of theta is greater than 0, what quadrant am I trying to describe? Why? All students take calculus. Where is cosine negative?
2 and
Right, so they're all positive here and cosine's positive here, so cosine's negative everywhere else. Right? And then where is cotangent positive?
1 and 3.
Yeah, you gotta be careful with this because in order to do cotangent, if you're using this diagram, in order to do cotangent, you have to reference tangent. Right? Cotangent and tangent are positive in the same quadrants. So cotangent is positive when they're all positive or where tangent's positive. So here I'm trying to describe quadrant 3.
How come it's not positive in the C region?
C stands for cosine.
How come like,
Right, when I describe this, all students take calculus. These stand for specific things. I know that cosecant and cotangent and cosine all start with C, but this particular C stands for cosine.
So it stands for the first one, and
This particular T stands for tangent, and this S stands for sine, and this all stands for all.
so cosine is less than 0. So would that mean, like, to me, like, I'm just confused because I would think the purple part is the one that's negative.
Why?
Because it says cosine is positive.
Cosine's positive, but
I'm just confused.
cosine's the green one. Cosine's the green. Cosine's where I shaded green. Cosine less than 0 means negative. Cosine negative. If they're all positive here, and if cosine's positive here, this is where cosine's negative.
Okay, so it is positive, right? By this, by
Here,
by
positive here.
calculus.
Yes, this is what that means. The C
Okay.
here means cosine positive. But I didn't shade it because I wanted negative.
Okay.
Right, less than 0 means negative.